Ladies and gentlemen, good morning. This is Bruce, G4ABX. Today we're going to talk about the construction, and I will actually assemble the solar controller, which is essentially what you see on the board in front of you. This is just a piece of plywood, 400 by 800, and placed on here are all of the items that we need to make it all work. I'm not going to wire it up while you all watch because that will be boring, but I do want to just talk through the components here, why we've got them, where we've got them, and a few things that you need to know before we start. Right, the first thing to talk about are the tools that you need. Not very complicated and not very many of them. A couple of Posi-drive stroke Phillips screwdrivers and a flat blade screwdriver, because the Victron charge controller requires a flat blade screwdriver for its compression screws. A couple of other things you'll need: a couple of Allen keys, again nothing very spectacular, and it'll depend what it is you purchase in terms of a fuse block, but this one here needs these two different sorts of keys. So I'm going to run through, starting at the base here, what we've got and why, and then I'll go to the top and explain how it all comes together. First thing you'll notice is there's a couple of fuse blocks on here. These are 100 amp fuses, and these will be supplied by the two battery packs that I've got. So I've got a 105 amp hour LiFePO 4 battery. And I've also got two 30 amp hour LiFePO 4 batteries that I'll connect in parallel. So we've got about 165 amp hours of LiFePO 4 battery capacity to run the whole system. These batteries then connect into the main bus bars. This is the positive bus bar, this is the negative bus bar here. With the main battery connections, they go through this isolator switch here, and the isolator switch is quite useful because it has multiple positions. So it has an off position, of course, everything needs an off position, but this one has two on positions, or three in fact. Battery 1, battery 2, or batteries 1 and 2, and batteries 1 and 2 is the position that it'll mainly be operating in this project. This is a 1000 amp breaker, so I don't think we're going to have any problems with power capacity. So that will fix on there and connect through to the positive bus bar. The positive bus bar then is connected to this breaker, this 30 amp resettable breaker, which feeds the inverter. This is the pure sine wave from Victron, the Phoenix. It's a 12 volt 375 watt inverter and will supply the mains power that we need in the solar powered shack. The negative feed from the batteries connects into this shunt, which is a Victron shunt that runs in conjunction with this Victron energy meter, and this is the device that will give us all of the necessary information that we will require to make sure everything's working fine. It's pretty simple. It's got some good connectivity, and I'll explain more as we go through, probably not today, but as we expand and add things like the Raspberry Pi to this system, I'll explain how this can help us. So the outputs from the positive bus bar are all separately fused. These are 30 amp fuses. There's an LED which shows if a fuse has blown, so you immediately know which fuse to replace. And one of these fuses will be connected essentially to this supplementary fuse block here, and this is the one that will provide the loads that go off the board. So majority of the loads, low voltage loads, 12 volt loads, will come from this fuse block here. For amateur radio purposes, mostly we run amateur radio equipment off 13.8 volts. And this device is a DC to DC converter which has got 10 amps of power output at 13.8 volts. The good thing about this device is that it'll maintain the 13.8 volt output for an 8 volt to 40 volt input change. So as batteries deplete on the system, this thing will actually hold the power constant. And therefore I will have from here 6 13.8 volt outputs that will go to various parts of my radio equipment in the shack. This will be connected into the bus bar and it'll pretty much look after itself. It doesn't get very warm. It's a very efficient means and much more effective than plugging a mains power supply into the inverter and converting back down from 250 volts to 13.8 volts to supply other items in the amateur radio shack. In terms of solar inputs, what we have here is essentially the isolating switch, a 32 amp DC isolating switch, and a couple of fuses that will be in series with the positive and negative feed from the solar panels. These are 15 amp fuses in here at the moment. It'll take up to 32 amp fuses. If you run two 200 watt panels in series, then 15 amp fuses are fine because the maximum current that you'll see from your solar panels is 11 amps. Obviously, if you were to put the panels in parallel, then 11 plus 11 is 22, so you'd see 22 amps flowing through the fuses, which would immediately blow them because they're only rated at 15 amp. So I will get some 30 amp fuses if we decide to put the panels in parallel. Let's just talk for a moment about why we might want to do that. I'm keen that anybody that's doing this sort of project for the first time doesn't exceed around about 40 volts output from their panels. The reason for that is that it's generally accepted by the international electrical agencies that in the dry, 60 volts is the point at which you start to be concerned about electric shock, and in the damp or the wet, like outside, 40 volts is the voltage that you start to be concerned about such things. So I would recommend that for first-timers, I'm not exactly a first-timer because I've been experimenting with this for probably the last 3 or 4 months, but to keep the voltage low and the current higher, you would put your solar panels in parallel, and then you'll only have 20-ish volts of voltage supplying these units. But you will have around about, if you use the same panels that I've got, around about 25 amps, so we just need to be careful about that. So this fully isolates, so the signal comes from the PV panels into here and then back round to the switches, and that fully isolates your input. That's really important. You need to be able to turn the panels off. That will be mounted up here. From the output of this, we go into the MPPT solar charge controller. Now this particular one is a 100 volt 30 amp device, which means its maximum input voltage is 100 and it will provide 30 amps of output current. That 30 amps of output current is connected to this breaker here, similar to this, in fact they're identical breakers, another 32 amp breaker here, and that will isolate the output from the charge controller. It could also isolate any conflicts that might exist further down the system, because this is essentially going to be used to charge up our batteries. So isolation and fusing, really important. Don't skimp on isolation switches or fusing, or you will find yourselves in a bind at some point. The cabling, I've kind of already prepared that. So this has got the crimped ends that I talked about in a previous video, a couple of lugs on there, I'm not going to bore you with me building the whole thing while you watch, but I will video it in real time and speed it up, so at least you'll get a glimpse of what goes on. So that's about all I want to say now about the potential build of this solar charge, solar power supply, if you like. And now I hope you have a very good day. And there we are. That's pretty much done. So solar power comes into the top of here, through some fuses, into the breaker, through the breaker into the PV side of the charge controller, out of the battery terminals into a breaker, out of the breaker to the bus bar. In the meantime, the battery supplies come in to the positive. The negative comes to the shunt. The positive goes up to the positive on the pure sine wave inverter. The negative is back to the common negative here. The 13.8 volt DC to DC converter is connected positive negative and provides 13.8 volts, pretty much guaranteed, to the output charge, the output fuse block, which at the moment has just got one 5 amp fuse in it. And there we are done. That wasn't too difficult, was it?